Welcome back, everyone. I hope you had a good lunch break and maybe even had the opportunity to be part of our networking, online networking. So welcome to the Track 1 afternoon segment. If you have signed up for Track 2 that focuses on the governance framework, this is your opportunity to switch rooms. So if you hear me, you are in Track 1. If you want to switch to Track 2, please follow the designated button in the lower part of your screen. So Track 1 right now will focus on the sustainable digital transformation of the agricultural value chain. And today there will be 2 sessions of Track 1. This one, the first one, will focus on the state of play by highlighting different perspectives on the topic. And the second session later this afternoon at 4 p.m. will put a light on the needs of different stakeholders in the field to make the digital transformation a success for all. During both sessions today, you as the audience will have the opportunity to hand in questions to raise questions. And to do so, please use the chat, which you can find on the right part of your screen. And please also, you can already hand in questions during the experts' talks, so we can get into the questions right away. We are not sure if we can address all questions, but we will do our best. So with that being said, I would now like to introduce the moderator of this session, and it's Professor Dr. Spiros Fountas, and he's the editor-in-chief of the Elsevier journal, Computers and Electronics in Agriculture, since the year 2014, and he's an associate professor at Athens Agricultural University since 2013. Spiros, thank you very much for being with us. The floor is yours.
Yes, thank you very much, Martin, for the introduction. Welcome everybody in this very exciting session, which gonna be discussing about digital transformation at the agricultural value chains. So we're going to hear a different perspective. This session is about the state of play. As we know, digitization is very important. It's going to take to change a lot of the agriculture today or in the future. So we have many issues that digitization will play a lot of importance. Have a lot of importance. So first of all, it's going to be the Green Deal, which is actually coming. Then we're going to have the new CAP for the Common Agricultural Policy. To hear all of these views, we have actually five very distinguished speakers in these sessions who are going to discuss many issues from the bottom up, from farmers' perspective, primary production, also from the consumers and the food perspective. We're also going to hear what is going to happen with the data transfer and the data ownership issue. So I think it's going to be very interesting session. And as Martin said, please send us any comments when you hear a presentation. Of course, we're going to take one question at the end of its presentation. But in the end, we're going to have also time for discussion. So from this one, should we introduce the first speaker? So I'm very happy to introduce Milica Trajkovic from the Biosense Institute. So Biosense Institute is a very well-known institute in Serbia, Eastern Europe. It has become one of the major players in EU projects over the last years. One of the projects actually that they have been coordinated is Antares. It's 30 million projects from the European Commission, of course, co-funding with the Serbian government to make a center of excellence in the digitization in agri-food with excellent infrastructure and researchers. And Milica is the head of business development department at the Biosense Institute, and she's responsible for the building new and maintaining and fruitful partnership network of the institute, both with industry and also academia across Europe. So the floor is yours, Milica.
Peter, thank you very much for your kind words and a really great introduction of the Institute. I will now try to share my screen. Just a second. I hope that now you can see my presentation. It is going a little bit slow for... Oh, here it is. So, good afternoon, ladies and gentlemen. I'm really honored to have the opportunity to open this session. And to speak more about farming perspective on digital transformation. So if we want to, generally speaking, know if some field has the potential for growth, it is a good way to see and to test the investments in this field. So if we check farm tech funding for the previous 2019 year, we will see that there are some quite huge investments in this field. 4.7 billion was invested, with the biggest deal of more than $200 million. But the main question and the main issue right now is what actually do the farmers think about all of us trying to digitize their work and introduce all the advanced technologies into their, well, conventional and traditional sector. What I like personally most about farmers is that there is no gray zone. So it's very clear if farmers like the solution, if they find it useful or not. So in the upcoming minutes, I will try to summarize some findings from the Horizon 2020 IOF project. Of course, just a disclaimer at the beginning, the project is still not finished. We still have 4 more months to work on. So these are not the final conclusions out of the project. These are just outcomes of our work. However, please stay tuned, and the recommendations and the official outcomes of the project will come during spring 2021. So basically, this project has more than 120 partners all around the Europe, and we are running 33 use cases in 5 main domains, so-called trials. What is really important here is that we as a IOF project, are nurturing a multi-actor approach, meaning that out of all those 120 partners, we have end users, we have farmers, farmer organizations, and many others, end users of the solutions. We have infrastructure providers, IoT integrators, researchers, and all of them are working together. How? We took something from the startup community, and so that is a lean startup approach, and we combine it with the multi-actor approach. So what does this mean? This means that we are trying to, let's say, motivate our use cases not to develop the solution from the beginning till the end and then to go to ask farmers what do they think about the solution. But as soon as they have the minimum features that are enough for testing it, to go directly to their end users and test it. Of course, the project provides all the technological ecosystem and business support. But as you can imagine, this approach requires a structure, firm structure. However, taking into consideration 5 different areas and 33 very different and very specific cases, we needed to be flexible in all these procedures and all our efforts towards the end users. So basically, this is it regarding the background of the project. I just wanted to present it in order for those that are not familiar with the project, to be able to better understand. I will now go to the findings. So what did we do? We performed user acceptance testing in several iterations. Plus, we did a lot of demonstrations. Basically, more than 70 demonstrations last year were done by our use cases. So those two are basically the most important sources for this presentation. I will not talk about the literature review. Of course, we did it. After that, we did a quantitative analysis with a questionnaire. And after that, we introduced, we had actually interviews, face-to-face interviews with farmers that are testing solutions of our use cases. The framework of user acceptance testing is now presented. So we have 4 components that are important for even for intention for use of the technologies. So we have usefulness, productivity, ease of use, knowledge transfer. If all those criteria, if all those components are fulfilled, and if farmer is satisfied with them, then he has intention to use it. However, it is a long journey between intention to use and actual usage, actual adoption. Where we have also perceived economic value and facilitating conditions. Through the examples in the upcoming minutes, I will tackle all of these components, and I hope that it will be very clear what farmers, at least from the IOF perspective, think about the Internet of Things in agriculture. Due to GDPR and many other regulations, I will not precisely describe which use case it is all about. I will just present what a field for the field is, the country of origin, and some general description about the case. So we have the first example comes from the Netherlands, from arable sector. And they're trying to define specific field management zones for potato production, and basically provide variable rate maps in an easier way than compared to the manually done. From farmers that tested this solution, we received feedback that it's very easy to use and it's not rocket science. So basically, this is a very important aspect. So ease of use. If the installation was good, if the design was good, and convenient to the farmers, and if they receive support if something happens. However, this particular case had 2 negative aspects, so negative points from the farmers. They said that the solution is not interoperable with other existing systems, which caused extra work for them, which is not something which should be done by farmers. And they also said that application needs data. I will not talk now about data, but I warmly invite you to stay with us at least till the end of this session, because my dear colleague Jürgen van Geeten from ILVO will tackle this issue. The next example comes from dairy sector, from Hungary. And this system actually produces a small rumen bolus that monitors various different characteristics, so temperature, rumen, and the body activity, pH level, and so on. And of course, it is linked with a cloud-based server. Besides obvious objectives of the farmer, he realized that selling the animals already with the installed, let's call it installed, bolus and health history, proven health history, can actually increase the economic value of the animal, so he can earn more money. He said that the system is reliable, and he feels safe while using it. Feelings are a very important aspect in a farmer's work. So this is also a field which should be addressed by the technologies. One good example of lean multi-actor approach and lean iterations is that in the first iteration, this solution was providing more notifications than needed. For example, on every several hours, the farmer was notified if the cow didn't drink the water. So in the next iteration, they realized that it's not needed. The notification is needed just in case if it didn't drink water for days. Now we're going to Mediterranean use case, a really interesting one, because it is being implemented in two different countries, in Greece and Spain. And it is all about optimization of olives production and olive oil production. From farmers' side, the objective is to get better understanding of the needs and of the watering needs of the olives. Sorry. So when I say farmers' objective, just to maybe clarify, you can see the use case as a one coin with two different sides. So one side is farmers' objective, which in this case is better understanding of watering needs. And the other side is the technological side. So there, the objective is probably creation of a sensor with a certain sensitivity and so on. So this presentation is focused on farmers' objectives. This particular farmer said that they had adequate farm size. However, that is not the case with the other ones. So this might, as we all know, this might be a problem for adoption of technologies if the farm size is not adequate. So there are a lot of small farms all around Europe. So this is a huge niche which has potential to be addressed. The second thing that I would like to stress here is that how this farmer formulated it. You can have your money back, your investment in a year. I mean, just to save the diesel back and forth. So farmers do not speak the language of return on investment, payback period, and so on. The explanation of their practical gain out of some technology needs to be really clearly defined. The negative side is the advertisements, so the communication between the product and farmers. I will speak about this later. I see that I have 3 more minutes, so I will speed up a little bit. The next example comes from Spain, from the meat sector and beef production and information sharing among beef supply chain. So farmers' objective is really to increase the knowledge about what is happening on the farm. And from his side, the positive side is that you don't have to be in the land, so he can track everything by the phone, which is very important since we realize that farmers also do matter and do care about work-life balance. So if the solution helps them address this, and if it makes their life more easy and comfortable, and they have more time for things outside the work, it will, of course, provide more benefit for them. Difficult if you don't have the structure in your farm. This is also can be related with the size of the farm and, generally speaking, the structure on the field. But I would like to stress in this example the last sentence. So we knew that in the other case they hadn't worked very well. In farming community in every region, you have, now I will use a modern term, influencers. So you have those that have a proven history of work. They have their successes. However, they're also very popular, and they have their opinion has the impact on other farmers. So it is very important to be careful while approaching this type of farmers. If they have bad opinion, or if they don't value the solution, then it will be a huge problem for everyone that is trying to come into this field. Instead of conclusion, so as I said, IOF is not finished. Keep in touch with us for the final outcomes, but something which is, so to summarize this presentation, so farmer needs to have all the convenience. So more than 50% answered our questionnaire with a mobile phone. Language barrier, so English probably in many cases will not be the best language to use. Promotion, use the adequate channels, take care about vocabulary, and make it convenient for farmers. Usefulness, so as we saw, usefulness is valued as it meets expectations and demands from farmers. Ease of use leads to the adoption of the solution. Of course, low-cost technology, we heard about it during the before noon session. It is sometimes a good approach, but what the approach that the IOF is really nurturing is the replicability. Age is not something which is proved to be very impactful on IOF project, so we will not agree with a lot of other sources that say that younger farmers are more into this, more into new technologies. Knowledge transfer, yes, just 5 seconds more, just 5 seconds. And the last one, since the knowledge transfer is extremely important, please feel free to keep in touch with Nefertiti and Farm Demo training kit, which will provide you with the inputs of how to demonstrate your solution to the farmers, and of course Smart Agri Hubs projects, which is into digital innovation hubs for the agriculture. I'm sorry for being 1 minute late. And of course, here is my email address for all the questions. Please feel free to send it to me.
Yeah, Milica, thank you so much for this very interesting presentation and make it possible in 15 minutes to summarize the 30 million EU projects. The IOF 2020, it's the flagship actually project from within the digitization agriculture, very interesting. You actually gave us the necessity of change. You cover all the 5 areas actually in agriculture, livestock, and crop production. Martin, do you have any question for the audience, or should I?
Yes, we do have one. I want to bring it right now. So how did you define your first minimum viable product? What features were included?
Yes, thank you very much for the question. This actually varies from the case to the case. The minimum viable product could be described, there is one great picture, how I see it. So minimum viable product is a donut, and the end product is a, that huge donut with a lot of crispy things and chocolate and so on. So the basic donut is something that serves its purpose, so we can eat it. It's minimal features that the solution has. The end one, so different white chocolate.
Oh, I think we lost the connection. No, I think now we are back.
Oh, sorry.
Yeah,
so do you hear? So just to repeat last sentence, I don't know if you've heard.
Maybe the last 2.
Okay, so the minimum viable products could be the donut that serves its purpose. So it is there for us to eat it and for us not to be hungry. However, the donut with white chocolate and some crisps around and so on, that is something which is being built on the way with our end users. So based on the feedback from the end users, we create that final product. So I hope that that it describes well the.
Yes, actually, that's very good answer. Milica, I think everybody will actually remember the donut example. It's always everybody just stated the donut, so it's very good everybody to remember, even for me. I'll keep it. Thank you very much for your presentation, Milica, and for your time. We'll come back in the end of the session with more questions.
Of course.
So we move to the next speaker? Yes, so the next speaker, I'm very pleased to invite Professor Dr. Cornelia Welchen from the ATB in Potsdam. So Cornelia is very famous professor in area of digitization and agricultural engineering. She is actually head of the ATB Department of Engineering for crop production and chair of agro mechatronics at the Technical University of Berlin. And she is going actually to give us a very good state of play for the upstream sectors. So how the digital transformation actually fosters sustainability in primary production of biomass. So the floor is yours, Cornelia.
Thank you very much, Spiros, for this introduction, and also thank you, Milica, for the very good introduction to Farming 4.0. That saves quite a lot of time on my end. Yeah, I want to talk about digital transformation and how it can foster sustainability in primary production of biomass. I want to start with the sustainability in agriculture, like the Global Environmental Facility and FAO are defining it. And the main goal is that we have to embed sustainability in agriculture, not focusing just on maximizing yield, but also on safeguarding and making more efficient use of natural resources. And that means we have to transform the way we grow food and protect our environment with innovation, technology, and youth, and make agricultural systems more resilient to the impacts of climate change. And the very highlight here is also capacity building. Access to up-to-date information on sustainable agriculture is crucial for the worldwide uptake. Yeah, how can we reach these goals is the big question. And I just want to ask, who of you knows Harari's book, Sapiens, A Brief History of Humankind? If you read it, or otherwise, you probably know that the agricultural revolution started roughly 12,000 years ago. And the core was that we could feed many more people from reduced area of land compared to the hunter and gatherer lifestyle. But everything comes at a price, and the cultivation led to a reduction of the menu to only a few main fruits and domesticized animals: wheat, rice, corn, potatoes, millet, barley. And believe it or not, these are still the main fruits that we are feeding off. So Harari concludes we still feed today like the very first farmers. And we also apply the same principle today, only technology has changed quite a bit. So 12,000 years later, it's due time for a change. But what would we have to change? The underlying effect of the agricultural revolution was increase efficiency by reducing diversity. That is what we call standardization. And the efficiency increase has become one of our major economic principles, and also the economy of scales. To produce more of the same comes at a lower cost. But the big downside of standardization is reduced diversity leads to a lack of resilience, and a lot of hunger periods over the course of the last 12,000 years has shown that this is true. And you can also ask your bank account manager, he will tell you the exact same thing. Diversity increases resilience of risks. So a second agricultural revolution has to be started to turn basic principles upside down, that we need diversification instead of standardization. And we need to find ways to manage this diversity with the same efficiency as standardized systems to increase resilience and sustainability and productivity at the same time. Now, the good news is industry is actually doing it, and they call it Industry 4.0. 4.0 because there has been 4 big industrial technology steps from mechanization, rationalization, automation to digitalization, or I actually prefer the word informatization because that's what it is about. We have information at our fingertips, or better, at the fingertips of our tools and devices everywhere and always. What is the core of Industry 4.0 is the adaptability and flexibility to adapt to volatile market demands and the individualization and customization. Now, this means diversification instead of standardization, and that is what we are looking for also in agriculture. And the technologies include our availability of digital knowledge, autonomous self-configuring cyber-physical systems, and especially important, the automated knowledge gain and cognitive analytics. That means the machines now can make their own decisions. That's really for the first time that this is able to work like that. And of course, scenario simulation and virtual reality, or things like digital twins, also come into play here. And this actually is a technological revolution. And if we apply that to agriculture, how can that help sustainability? And I have a quick comparison here of Industry 4.0 with a high level of complexity and the connected information flow from customer to production enables individualized and customized production at mass production conditions. So the flexible management of the production process aims to cope with diversified output requirements in a controlled environment. Now in agriculture, we have an even higher level of complexity, and the connected information flow is actually not so much to the end user, the consumer, but from the site-specific information to the farmer and the decision taker. We have to enable individual and specific system control to adapt those cultivation methods to natural heterogeneities, to enable massive production while considering site-specific and environmental requirements. And I call that the management of diversification by adapting production processes to natural heterogeneity of the environment. And if we compare the two main developments in agriculture that we're seeing today, the controlled environment agriculture is more or less doing what Industry 4.0 is doing. It's working in a controlled environment. It's called controlled environment agriculture because it's indoors and we control the environment. The outdoor farming is what I call the environment controlled agriculture, because now, and this is the new revolutionary principle, that we look first into the environment and we attach everything that we do to the environmental conditions. And there are, of course, first steps like precision agriculture and the like, but we have to go further and beyond that. Now, what are the digital tool sets to improve environment controlled agriculture, or to improve sustainability in agriculture? We first of all have to look at the agricultural production systems themselves. We have to make good decisions in the very beginning, looking at crop rotations, selecting ideal crops for the situation. This is always the first step which is required. Second step on top of that, we can start the automation of work processes to make them more precise and to apply the exact amount at the exact space of the right media in the field. And the third part is, of course, the knowledge gain and the knowledge management, and that is what really drives the digital transformation right now. And this is why I prefer actually the informatization as the core technology of this digital transformation that we're seeing right now. It is very important that we incorporate as much domain knowledge and expertise as we can into all these digital tools, because otherwise the result will not be what we have been expecting. And the last part is the availability of information. We, of course, need technology for that. We need connectivity and knowledge transfer, and everything has to be incorporated into knowledge and databases. And, of course, the capacity building, the access has to be available to use it. And that is not only large farmers in well-developed countries, but it has to be available for small farmers and all around the world. Now, what are the challenges and how far have we come? The challenge is if we integrate environmental goals and sustainability goals into agriculture is, first of all, the variability in time and space, but that we even increase the complexity for our control system, and that these environmental goals are independent of the production goals and have even longer response times. Or if we look at it in a control system cycle, we have our data acquisition, interpretation, and decision taking coming to the management measures. And then we have the real world physical system. And only at the end of the season, we get the reaction of our agricultural production goal. But the environmental goal will take maybe 4 or 5 years before something even changes in the groundwater system or in the neighboring forest. So this is a real challenge. So precise knowledge-based automated cultivation systems for agriculture are a first step, but then the environmental goals have to be added, and they might be added into these control systems as disturbance variables, but also they have to be looked at how else they can be integrated. And now if we look at some of the science that's going on, these are some examples from ATB. In order to reduce losses, we try to increase the quality of the produce right there at the tree by adding sensors. We are looking at reducing chemical input for plant protection by only applying the plant protection chemicals where and when it is required, and we're developing sensors for that. Same in this area of fertilization. We're looking at sensors that can analyze the soil on the go to adapt the fertilizer amount to the exact requirements in the field. And we are looking and analyzing production systems in order to improve the gashouse emission rates and or the water productivity, and this is done with a lot of modeling and analyzing. And finally, if we want to set up these systems, all of this is increasing the amount of work that we have to do, and we need automation and robotics to actually finalize the work that is required. Now I have to speed up a little bit. I'm seeing that time is running out. If we connect the environment, we are increasing the scope, and we have many more different fields of applications with different resolutions in time and space. And this is, of course, a big challenge for everyone who is trying to gather this information. And one big issue is that the indicators for sustainability in agriculture are described and they exist, but not so much as measurable, machine measurable indicators. So we need a lot of work here to actually develop sensor systems to make these indicators measurable for machines in order to use them to improve sustainability in our production systems. Now, I'm finalizing with my take-home messages. Sustainability requires resilient production systems. Resilience is increased by diversity of production systems, and sustainability requires economic drivers. So we have to define values of ecosystem services. And environmental goals for agricultural production systems increase the complexity. And like I said, a second agricultural revolution is required to put diversification instead of standardization as the main production principle. And let me mention that we have heard it before today, but digital transformation is not the solution, but it provides very powerful tools to address very complex problem statements. And the domain knowledge is very important. It's core knowledge. Deep learning analysis of the status quo data will cement the status quo and will not lead to innovation. This is so important to keep in our minds, that we need to add innovation into our data sets. Otherwise, we will not have the machine learning systems do the job for us. And access to up-to-date information on sustainable agriculture is really required. And last but not least, let's get started. We have to do it. Every farm can apply individual steps in practical agriculture today. Don't wait for digitalization to be finished. It will never be finished. Just get started. Thank you very much.
Thank you so much, Cornelia. That's a very interesting presentation indeed. And thank you for being on time as well. We actually save us a few minutes as well, 20 minutes, sorry, 20 seconds, so that's very nice. You actually gave us a very good idea and very good impression of the upstream sectors, even the examples of ADB covering more or less majority of the sectors in agriculture were very good to illustrate this. So Martin, do you have any comments or questions from?
Sadly not. Maybe it was so interesting that people are still processing. So there is no questions from the audience yet. To the audience, feel free to hand in questions that
Yes,
or that we can also address after all the talks. But maybe you have a question.
Yes, if you don't mind, I would like. I mean, actually, from your presentation, Cornelia, actually, I really took this what you said, that we don't really have to call it digitization actually, but call it informatization. So it actually is the first time for me that I hear, but it actually makes sense to me. But it would be nice actually to elaborate a little bit further, because we have a large audience, and this messages, statements should actually pass across the audience. So could you please elaborate on this?
Yes, thank you very much. The point is, where does digitalization start, and what makes the difference if we compare it to automation? If you remember the slide with the 4 technology steps. So automation has actually started in the 70s, and it started when we added the first computer systems to our machinery, and the first robots that have been implemented in production lines date back to the early 70s. So this is why I think a digital approach is not really new, but what is new is that we have digital data and the knowledge and information that we can derive from the data. So for me, the development step, or the revolution, like it is called, the technical revolution, is really the cognition that machines can take decisions on their own. They become so smart that they learn from the data they have gathered their own, and they can take their own decisions. And this is, I could also call it datarization, but that's not a good word. And so this is why I like the informatization. I will not change the wording, because now we are in the process of the digital transformation, and it's okay. I can adapt to that, but the core is the cognitivity of the machines, the data that we are using to derive information.
Perfect. That's a very good comment. And we have to take into account that digitization is actually all about data. And that's actually what it really matters. And then from how to, as you said, transfer data to information, and this is actually to decisions. That's the most important thing. We have to have the whole flow because the decision is the most important. Again, thank you so much for this very interesting presentation, and I'm sure we're going to be some more questions in the end. From actually the upstream sectors, now we're moving to the downstream sectors, and I'm very happy to invite for the presentation Karen Hamann from the Institute for Food Studies and Agro-Industrial Development from Denmark. So Karen has worked with business development, innovation and technology in the European food sector actually for more than 25 years. And she's going actually to give us the insights about the digitization automation in the food industry, implication for skills and science. So the floor is yours, and thank you very much for joining us.
Thank you. I'll just see if I can share the screen. So, thank you very much for inviting me. I've been looking very much forward to come here today and to share these findings with you. I'm going to talk about digitalization in the downstream sector, focusing on the food processing sector. And my perspective will be particularly on the work and workers. My background is in a Danish company. I have a consultancy company based north of Copenhagen. I do applied research in food and agribusiness. And the results I will be presenting to you today have been produced in a project funded by the European Union and organized by Food Europe and EFAT. And it was a project about digitalization in the food industry and the implications on professions and career paths. So this is the perspective I will share with you today. The project was carried out in 2018 and 19, and the final report has been published. And the project looked into what kind of new technologies were being implemented in the European food processing industry, both with very small companies, but also large multinational companies, and of course all sectors. We looked at the emerging jobs that came out of this and how these new technologies impacted on the skills required among the workers and how these workers were trained to acquire new skills. The project aimed at concluding what approaches, joint approaches involving both companies as well as the workers' associations could underpin a successful transformation to Food Industry 4.0, thus taking into account both the views of the companies as well as the workers. To achieve a pan-European approach, we organized 3 regional workshops, one for the Northern and Atlantic countries, one for the East European countries, and one for the Central European countries. And for these workshops, we discussed technical issues, work issues involved companies and trade unions, and with a very good and creative discussion. And these are the findings I will share with you today. As it has been mentioned earlier, Industry 4.0 is about integrating technologies. And in the case here, we're looking at technologies where we have lots of information, but we also have some structures like machines and robots. And how do we then combine these technologies, some of them being very, very large structures like a whole production line, and some technologies being very small like handheld scanners. So you find these integrated and digitalized technologies all over a food factory. But yet there are vast differences, because taking a traditional industry like the food industry into account, we need to see whether we actually find digitalization and new technologies. And I've tried to put this together to share with you this perspective, because food production is very much about craftsmanship and knowledge and how to do things, and you have the experience from working with this with your hands. But it's also a matter of having installed long production lines, you have the factory outline, and you have some different machinery types which have to work together. On top of that, there may be some automated systems or automatic devices where only part of the production is automated, and across everything you're collecting data. So the internet and the connectedness, binding these issues together, that is the core of a modern food factory, being a very small company or being a large company. And to add to the complexity, if you look at automation in the food industry, it's clear that you cannot just automate every production line across every industry. But you need to see that most of the automation is already carried out in the front end of the production line, meaning where the raw materials enter the food factory, like the dairy where the milk comes in, and also in the final ends of the line where you do the palletizing and the logistics. It's very common to have palletizing robots and very few people working in these facilities. On the other hand, the more complicated functions like cooking and cutting and picking and filling, etc., requires much more manual work because it's much more delicate items and the processes are very difficult to automate. And this brings us back to the issue about work, because from these, what I have shown you here tells that you cannot have skills for only working in a food factory, but you would need very diverse skills to man the different stations and also how the work is carried out. This means we also need to care about the people working in the food industry. And the food industry is a very large employer, among the largest, if not the largest employer across the European industries, and a very stable employer, providing over 4 million jobs, meaning that a lot of people depend on work in the food industry, and the food industry is highly inclusive. So here you find both newcomers, you find refugees, you find senior workers, trade workers, and a lot of people work here. What shows you here on the pictures is that digitalization occurs everywhere. You have examples of artisan bakeries with an automated machine. You have senior workers testing temperatures. You have digitalized factory outlets where you are testing a control procedure. And also, for example, in the meat industry, you have digital sensors weighing the boxes where you have the meat flows. So you have digitalization across practically all types of work and all functions carried out. But as more and more technology are coming into the food factories, it's also clear that we will see a change in requirement for skills. And we based our project on the approach proposed by McKinsey in their automation study. And a major conclusion, which was in the McKinsey study, as well as we could document in our FF Footprint Europe study, was that the need for physical and manual skills among workers would be significantly decreasing and would turn into more inspecting and monitoring work, whereas the need for workers with more cognitive skills, social skills, and certainly digital skills would be highly increasing. We could illustrate it this way by saying the set of manual skills becomes less important. Cognitive skills, where the workers are required to take on responsibility, to think and act, to collaborate, would be much more important, as well as social skills, inclusive skills, empathy, language, working together. That kind of issues would become more important. Across this set of skills, you find digital skills, because, as I said before, everybody working in a food industry or a food factory will be required to work with digital data one way or another. On top of this, we cannot eliminate the importance of having craftsmanship skills available to the food industry. And such craftsmanship skills remain relevant, particularly in the meat industry, in the bakery industry, in the dairy industry, but certainly also when we look at the technical parts like mechanics and electricians and so on. So craftsmanship skills and digital skills underpin the work going on in the future food factories. One of the questions we asked at our workshops was, how do you think of future worker? What would be the profile of a future worker in the food industry? And the two main issues brought forward in these workshops was that we think that a future food industry worker would be a highly specialized super technicians with adequate IT skills, or ability to work in a flexible context, think and act, and be open to changes. Another issue was that a worker is a person who can deal with more complex matters, takes some responsibility, and is flexible to shift between tasks. And both of these two profiles point in a very opposite direction than just if you work in the food industry, you man this machine. So we are talking about a whole transformation of the way to work and the skill sets required, and also how will this then affect the companies, and can they recruit people for this in the future? That's another issue. But as the complexity of the manufacturing increases, it also leads to a new way to organize work. And Industry 4.0 does lead to changes in work organization. What we learned from our project was that particularly working in teams across workstations and in project-oriented work would become much more important. We had situations described to us where customers come to the company, say they need this kind of solution, and the company will then go to the workers who know about the technology and equipment, say, my customer needs this, can we actually do this? And here comes the value of the craftsmanship skill and the knowledge of having the automated and digitalized production systems, because then the workers are trained to work together, think creatively, and can actually deliver the solution the customers are looking for. Another important issue when it comes to work organization is that one job becomes many tasks. So you cannot say, I have a job where I do this, but you will have to say, I work in a food company where I do all these tasks. And as for example, this could be taken from the meat industry. You work along the cutting line, but you also mentor newcomers who participate in the maintenance of the machinery. You're a member of the company lean team, and you also operate this digitalized sensoring system, etc., etc. So basically, you have to adapt to being able to undertake more tasks. An important issue when we look at digitalization, that is, we will see a polarization among specialists and generalists. And for example, a generalist, the new generation of generalists, could be industrial operators. They are generally trained to operate industrial equipment, automated equipment, and could be trained in industries like biochemical, the pharmaceutical, chemical industries, etc. But they're trained to run automated equipment. As the food industry becomes more automatic, these industrial operators are also relevant workers in the food industry, despite not having a food background. You will also see more and more specialists, particularly in the maintenance and the technical departments, because it requires technical knowledge to install and adapt and maintain these high-tech production lines and integrated data systems. So this means that we will also see new career opportunities for people to work in the food industry. And I think this is something which needs further exploration. So coming back to where I started to say that more and more technology will be implemented in the food industry. Companies do this because they want to grow, they want to develop their business. This is fair and understandable. But just because you install more advanced production machinery doesn't mean that the company will grow. You need to understand from the company perspective how to deploy these technologies, integrate these technologies with your existing factory layout, and how these technologies can actually benefit or improve your business models. So it's much more than just installing a new automated machine or a new digitalized system. You also need to look at this from the people's perspective, meaning that if you have more digital and automated technologies, you will require new skills among your workforce and also in some cases among management. And you will need to look for new ways to learn, because how do you train to become a reactive worker? How do you train to work in teams? It's much more than just being mentored along the line. You also need to see that if you can work with digital and automated technologies, you may have a new career path outlined in front of you, which may be starting in the food industry, but may not end up as being a food industry worker. You can change to other technology departments, you can change to other industries, or you can work directly with the digital companies. Because digital companies are also looking for workers who have this practical experience of running the equipment. So there we have a new interface between two new industries. So therefore, if we are to benefit in the food industry from having more technology, we need also to understand how to combine the craftsmanship skills with the technology skills. And this goes way back also to when we train the future workers into learning how to work with technology. And here we also need to consider new ways of collaborating between industry and technical colleges and other institutions for training both future workers as well as the workforce which we have today. We need to understand what are the needs for changing the way work is organized, because working along the line is very different from what we will see today and certainly tomorrow. We need to involve management and educate management also in understanding the new opportunities for the business models which can be generated from having much more data. The big data are not yet exploited properly in new business models. And here we also have to think that workers see what's happening every day. They contribute to generate data, they understand these data, and should also be involved into this. So there is also a big communication issue.
Karen, 1 minute, please. Yes, thank you.
Last slide. So putting these things together into a context of science, I would say that if we look at food industry 4.0 and work, there are lots of implications for bringing this closer into the social sciences, where we have work and work organization as one major issue. You have work and learning approaches as another major issue, and you have work and communication as a third major issue. So therefore, I just want to say that digital transformation in the food industry is highly relevant in a technical perspective, but certainly also for a human-centered approach, where we look at the demand-machine interface, we look at the man-organization interface, and we look at how to grow together with technology. That was my final slide. Thank you very much.
Excellent, Karen. Thank you so much for this interesting presentation. Actually, it's very good to hear actually what the food industry asks for the future workers, and digitalization is indeed a very important aspect. With all of the statistics you provided, you really depicted this change. Martin, do you have any questions from the audience, maybe?
At this point for that presentation, not, but also please post your question for the Q&A after all the presentations in the end.
Thank you very much. And just maybe, if you don't mind, Karen, just to ask you something, because it's for very interesting aspect, it's robotization as well. So robots will, in food industry, are more advanced. So it's done in primary production, for example, because food industry is more controlled environment. So robots, I guess, is could be easier applicable. Could you please like project us where we are before, where we are now, and where we're going to go in the next few years in relation to robotization?
This one illustrates pretty well your question, because where we are today is we have lots of robotic and automated functions in the inflow of the raw material, as well as the palletizing and logistics. The packaging departments are highly automated, and palletizing robots is almost standard. So that is where we are today. The next step, if we look at the palletizing and logistics, that's automatic vehicles moving boxes around unmanned. That's the next step, but also already implemented. If we look at more automated functions or robotic functions along the production line, the pick and place, where you pick something and put it into a tray, or pick something and put it into a box, is becoming more and more installed, because you're starting to have this kind of delicate robot which can sense what to pick and how to place it, because that's a delicate operation when you're designing robots. When you're looking more into actually working with the processing, it's much more difficult, because food items are not uniform, and that complicates building robots. You could take the case of the meat industry. A pig is not a pig from the perspective of a robot. So it's very, very difficult to automate the early steps in a slaughtering line. Whereas slicing meat for sausages can be much easier automated. So automation depends on what kind of materials are you working on, and how complicated is the function you're looking for. And I think that is the best way I can answer your question.
No, that's very clear. Thank you very much. Yeah, you actually gave us some research needs for robotization. Also,
yes, lots of technical challenges.
Which is a challenge again, especially for research and industry. It's very good to know, where the challenges are for the next steps. So again, I would like to thank you so much for this very interesting presentation covering actually the digitalization in the food industry. So thank you very much again. And then I will open the floor for Professor Dr. Nestle Sauser, who is a research professor in smart and sustainable food production at VTT Technical Research Center in Finland. She has more than 20 years of experience on food material science and food ingredient product design. This presentation now is actually about the digitization, how it's going to shape the consumer landscape. So we actually heard so much the primary production, the food industry. So it's time to hear how the consumers are going to be changed with the digitization. So the floor is yours.
Yeah, I tried to open it, but I am having some technical problem here, and I think that the technical problem still continues. Do you hear me?
Yes, we can hear you very clearly.
Okay, and
we don't see the.
You don't.
Yeah, it seems to start. Or it seems to process, but we can't see your screen yet.
Okay. I'm sorry about this, but I have been having continuously WebEx problems. So let's see if this will work. Otherwise, you can maybe move to the other speaker. Do you see my screen now?
Sadly, we can't.
Okay. How about we do like this? I go out and get in again, and then we switch to the next speaker in the meantime.
Yeah, I think that would be a good way forward. So all the best and good luck. And we really hope to see you and your screen back.
Yeah, I will join after the next speaker. Sorry about this.
No problem.
No problem.
Okay, so of course we are, in digital world, and things are not always technically smooth. That's always the case, but of course we all know that we're all using digital tools in everyday life. So then we move to the next speaker that I'm very honored to invite Dr. Jürgen Vajete from ILVO, which is the Flanders Research Institute for Agriculture, Fisheries and Food. Jürgen is the scientific director at ILVO, and he's also the head of the Department of Agri-Food Technology. I'm going to say Jürgen is actually a very well-known figure within digitization in agriculture. He participates in most of the flagship projects within the European Commission. He's got a lot of also ideas for new way of digitization, and actually it's very closely related to the first presentation from Milica about the Farming 4.0, and also what Cornelius just said about the informatization. So now the floor is yours, Jürgen, to discuss about data trust, which is very important. Thank you. We can also open your video, Jürgen, just to see yours. We see your presentation, but not yourself.
Sorry, I was a bit taken by surprise as I had to call in. No. Honestly, yeah. I was listening, and I would like to take the chance just very shortly about what just happened. That also indicates what our farmers are struggling. If we are still not 100% able to get actually a simple digital conference online all the time, how would we expect that a drone would stream information all the time to a farmer's computer? So let's not forget what a big challenge we are up to if we want to bring this technology to day-to-day practices. But okay, this is a small comment. I want to talk the next 15 minutes with you about the possibility, or how, at least at Ilvo and in our ecosystem, we are trying to build trust. Trust that you need to be able to create digital transformation in the agricultural value chain. And 1 second. Okay, I was already perfectly introduced by Spiros, but I think it's always very interesting for myself to just explain you a little bit why I am engaging in these kind of presentations and conferences. I've been an agricultural engineer. To me, it seems like all my life, and my fascination for farm machinery and equipment has been always there. And my role, mainly, I feel myself as a kind of an ambassador for precision farming and digital agro-food. One of the main projects that we are driving, except the very big ones, like, of course, IOF and where we are part, is also the ICT Agri-Food ERANET, which is very much at the beginning of my career as actually an ambassador for precision farming. And I want to stress that this is one of the typical projects that is putting emphasis on the fact that the value of data can only be there if we are able to transport it all the way over the value chain. So if data cannot make it from the farmer to the consumer, the value is not there. So this is very important for us to stress that. Another thing that is very important for us as Ilvo and for me personally is to bring real valuable products to end users, things that really work at farm level. And that is one of the reasons why we like to live by the adagio, under promise and over deliver. So going a little bit more on the focus on my presentation, why do we need trust? Why is it so important that we have trust? Well, that is because recent time there has come up a new concept. You can call it API economy, you can call it data as a product. We like to refer to it as data sharing 4.0. And if there is 4.0, there is 1.0. And to be honest, data sharing is not new. There has been data sharing actually long time before there was digitization. We share data even in physical documents, but we only share with our circle of trust. Here in Belgium, we would call it a bubble in these times of Corona. So it's only with your close partners that you're allowed to share data, and people that you really trust, partners that you trust. And actually, the digitization, or the first step to become digital, to exchange documents, didn't change that very much. You were still exchanging information only with your closest partners. And even if we went to the cloud, or we used FTP or API, we still wanted to share only with people we trust. But then now, we are in the capability to share our data with everybody. We can share it as a product, we can share it with people that we don't know, and we will probably also share it with people that we don't trust. And then this is the basis of a very unstable system, a system that cannot be sustainable if we don't come up with support. Support in three pillars. You need a good infrastructure, you need the trust, and this should be built on a basis of respect. How did we do that? We developed a system, a platform that has the components to bring the right infrastructure and to bring trust based on connectors, API management and API markets, access control, authorization, and a clearinghouse. Meanwhile, this platform has moved to a commercial available, or an available platform, which is called Just Connect. Maybe this is a quite conceptual way of approaching my presentation. So let's take it a little bit more bottom up. Let's say you have a perfect idea and you want to develop and deploy an app. Maybe you want to monitor the temperature through the whole chain from the farm to the consumer, and you start your own company and you have, of course, very good ideas. You want to monitor the temperature at different places. You want also to monitor it during transport. And you start at the beginning of the chain, you go talk to the farmers, you need data and information from his computer, but you cannot get that like that. You need to make a contract. You need to get consent to use the data from the farmer, and probably, most probably, there has to be a value exchange. This can be money. You can make also other deals, of course. You don't need to talk only to the farmer. You also need to talk to the government, for instance, that does checks on the health of the animals or quality management. You also need to go out and talk to laboratories. You need to talk to genetic companies working on genetics. You need for sure also to talk to the vets, And each time you talk to these people, you have to have a contract, you have to get consent, and you probably have to do a payment, or you have to give them some value back for their consent. So you see where I'm going with this, because this is not only about talking to one farmer, it's talking about to a lot of farmers, talking to a lot of vets, and you get a very complex system. And in this system, if one player decides to change his IT system, to change his mind, your app is blocked because you will not get access to the data source anymore. So if you see, I will go to the end. This is what we like to call, and I like spaghetti a lot, but this is a spaghetti system and it's not good. It's a total crossover between data providers and data users, and it's not a stable system. What we would like to see is to replace this spaghetti system by a circular system. A circular where data users and data providers are connected on a kind of highway that let the data flow from one player to another. And then if all these players are connected to a circular system and you come with your new app for your new company, you can just plug into the system. All the connections are foreseen. There could be one contract for you to plug into the system that gives you connection to all the actors on this kind of data, circular data highway. How did we do this in practice? I have another 9 minutes to explain you how we set this up. Our components are, as I said, access, authorization, and clearing control, and I will go a little bit more into detail for that. First, the infrastructure. For the infrastructure, it was Ilvo together with an ICT contractor who built the system, and we were financed by our founding fathers, who are one by one farmer cooperatives. They financed the development, and also an important part of the financing is coming from the European Fund of Regional Development. These are the people behind our system, or the companies behind the system. For the architecture, we use the reference architectural model of the International Data Space Association. This is very important for us because this is a model, or an architectural model, that allows us to be compatible with other data platforms, and also that is fully in line with the vision of the Commission on data governance, and with the visions of new upcoming initiatives, like, for instance, the Gaia X initiative. I will not go into detail. This is a more comprehensible way, I think, to look at our platforms. You will have the slides available. If you have questions, please send us an email, and our technical experts will be more than happy to give you more information on how our infrastructure is developed, or how our model, our architectural model, is developed. I want to move to the most important component. This is respect. And for respect in our data sharing system, we based ourselves on a very important document, the EU Code of Conduct on Agricultural Data Sharing by Contractual Agreements. I hope, and I think if you were this morning in the opening sessions, that you know about this document. It was being mentioned. It's a very important document. It's of course not law. It's a voluntary system to do self-regulation, but it gives some very important rights to the data originator, the farmer, and it's signed by originator, the farmer, all major players in the ecosystem. So it's well supported and applied. This system makes, or this code of conduct makes sure that we, if we want to share data, we have to tell the farmer what data are we sharing, with whom are we sharing, why, and how long. And a farmer can say no, or he can even change his mind. If he first said yes and he says no, I want to stop sharing, this should all be possible. So this is how we, where we get the basis of respecting the farmer in his ownership, so the code of conduct. And then if we go more into detail, we have to provide the farmer access control, and that we do by the digital identity of the farmer. Our Flemish farmers are acquainted with this system because they also need to use it from the Flemish tax when they have to submit their tax report. So we are using the same technology and the same application. Most of our farmers, they have 6 possibilities to use their digital identity, but most of them like to use an app. It's called It's Me. It's developed by some major banks in Belgium. It's also available more and more in other countries in Europe, if I'm not mistaken. But it's a very easy app to identify yourselves. So this, by having this access control, we create security. If we talk about authorization, I said that the farmer is in control. So that means if a data user wants to get data from a data provider, he has to get it approved first by the farmer. If the farmer gives his approval, the data can flow. Maybe this drawing makes it a little bit more clear. You have to understand that a lot of farmer data is already actually with the businesses. The milk processor or the dairy factory has quite some information about from the farmer, data from the farmer. Of course, it's owned by the farmer, this data. So if a software developer wants to get access to this data through an API, he needs to get consent of the farmers. If our farmers push the green button, the data can flow from the dairy factory to the software developer or the app developer. In this case, you see that 1 out of 4 farmers says no, and his data will not be transported towards the app developer. Of course, this is only an example, because there will be not one data source, but many data sources, of course, that will be transported towards the development of an app. You will not build an app based on one data source. In this way, by giving the farmer control over this red-green button, we respect his data sovereignty, and he stays in full control of his data. One last part is the clearinghouse. The clearinghouse is actually a very transparent log on our platform, where every data user can see which data sharing activities he's doing and what was his answer to it. So there we are in full transparency. And with this security, sovereignty, and transparency, we support this important component, respect. Also, something that I want to stress is that it's our choice not to build application ourselves. We are only the platform that transports data from one place to another. Developing applications is up to the ecosystem around us, and it's a way for third parties to make businesses. This is not only a PowerPoint presentation. It's a real platform. We launched it last year, at the end of last year, and we launched our first demo applications in the beginning of 2020. And also next year, starting of next year, the new applications will become available on the platform. The application that we are doing now is a digital auditing application that helps farmers, if they have a digital auditing on their milk quality, to actually totally reduce a lot of administrative burden towards a simple app with red, green, or orange. And if the app is green, they know that the auditor can come along and that they're perfectly prepared to be audited. We are not ready. We are building. We are moving forward all the time in trying to build a trusted data ecosystem. And we have some research and innovation activities that we want to research and innovation actions, actually, that we want to work on. We work on decentralized ideas. We are also looking at how to deploy AI models on top of our platforms without the need of data sharing. We're looking all the time to make our data sharing more efficient and to even make the trust grow. So technology that allows us to do more data access control is in our interest. We are a big driving force to develop one agricultural marketplace for data. So we are actively working on the development of the common agricultural data space. Maybe the most important one, we are still under development for innovative, sustainable business model. If you ask me, it's not the technology that is the issue, it's the business model that is the most challenging. And of course, we are constantly looking forward to transnational cooperations for further research. Because we develop our ecosystem regional, we believe that trust has to go regional. It has to grow regional with Flemish farmers in a Flemish community, but then later we will scale up and we will connect to other European platforms. And I want to take a little bit of your attention to get some attention to one of our upcoming events that is trying to support researchers to get to market with their developments. And it's on the 10th of December by the ICT Agri Food project. I think I can come to my conclusions. We create openness because we have a data ecosystem where all actors in the system can participate in different roles. We create trust because we have a clear governance and we have a neutral body being in the middle to follow up on the different roles of our actors. We create transparency, as I explained, due to the clearinghouse, and I think we are also creating huge opportunities as well for the farmers to stay in control of their data and to see where their data is used, to get benefits from the use of the data. And on the other hand, also we try to support the agri-food businesses around the farmer by opening possibilities for new applications with data. This is my talk. You can see our movie explaining Just Connect in YouTube, and we have also some other links provided here where you can see how our applications on the platform work. Thank you very much for your time.
Thank you very much, Jürgen, for being, of course, flexible in the beginning. As you say, digitization should be flexible. I mean, changing role in the presentation. But Just Connect is indeed very timely work and application. And your presentation was very interesting, again, very timely, because data trust and data applications are, of course, of high need. And it's good to see this collaboration between research organization, industry, together also with farmers. So many farmers actually are joining. So it's a very good example from other countries as well, like Germany and somewhere else. So Martin, do you have any comments maybe from the audience at this point?
Yes, we do have one that's linked to the presentation that was just given, and it says companies need to reorganize themselves in order to digitalize their processes. Do you have any suggestions on how to make it easier to get started?
I'm not sure that this question is asked from the perspective of the company, but what we are experiencing is that new companies that are engaging in the digitization have it more easily to connect and to step into our system than existing ones, because they are organized, they are already sharing data, but through other systems, for instance, FTTP or other technology. If they want to step into the API economy, most of them have to do huge investments, and they are not sure, to be very clear about this, that the revenue they have now on data sharing in the trusted group, that they will keep it in the open group, because you don't know if you open up the businesses to other, what if you will have the same revenue on data sharing. I don't know if that's fully answered to the question, but that's actually how we are faced with it. So that is what I can say about it.
Yes, thank you very much, Jürgen, again, for this, as we said, very timely and very forthcoming, actually, presentation. I'm sure there are going to be some more comments in the end of the session. So thank you again, and now we are very pleased to actually not only hear, but also see Professor Dr. Nestle Sozer, and also see the presentation.
Okay, great. I was going to have a heart attack. Is it going to work or not? No.
You know, sometimes we can also actually have the ordinary, like or traditionally, we could actually hear you present the story. So it's a digital world, so we have to be flexible. But it's very nice to have you here. I actually presented you, so now I don't have to present you again.
Okay, and let's check one thing more. Are you seeing one slide or two slides now?
One. So it's
great.
Slide view. It's great. So go ahead, and thanks so much.
Thanks. Thanks for being flexible here. So before I proceed with my talk, I would like to give a brief introduction to VTT. So we are a research organization located at Finland, and our aim is to tackle global challenges through scientific and technological excellence. We have a turnover of 245 million euros, and we have 5 lighthouses, which you can see on the right corner, and the Sustainable Food System Challenge, which I will talk a little bit about today, is falling under Resource Sufficiency Lighthouse. So we have to tackle or we have to find food and other resources to feed 10 billion people in 30 years' time. This means that we have to almost double the amount of earth resources from the point of water, energy, and food. So can we use data to enable sustainability in the food system? So can we create new economical growth opportunities through the food system data? So the answer is yes, we can. So I like this wording, which is more in the world of digitalization. Data is the fuel, and analytics is the engine. But I would like to adapt it more towards smart and sustainable food production system. So, what are the elements of a data-driven smart food system? Hyper-personalization. So it means that just production based on individual needs of the consumer. So moving from local to hyper-local food sourcing and distribution, especially in urban dense areas, and use of platforms and crowds for food production, delivery, and logistics, together with the food ingredient technologies. They are really the cornerstones enabling smart and sustainable food production. So why hyper-personalized foods? So I would like to bring to your attention a massive study done with 14,000 twins throughout a 25 years period, where they have showed that even the identical twins respond to same food differently. So why do we force in one-size-fits-all approach to our eating and diet? So what is hyper-personalized food? It's a new and smart way of food production based on the single individual needs of the consumer, taking into account the preferences. So in such a system, data should be collected autonomously through environmental or wearable sensors, and a data-driven system, as well as the smart mobile apps, should guide the consumer and provide recommendations. Of course, here the next generation smart machines are critical to produce fresh, healthy, and personalized foods. So sensorization of things is the key towards hyper-personalized food production, which is made just for your needs, taking into account your preferences and values. In 5 years' time, we will have about 75.4 billion connected IoT devices, which will mean roughly there will be 10 IoT devices for every person on this planet. So you can also imagine yourselves what it means from the data collection and data sharing perspectives. So why don't we utilize these AI optimized data platforms not only to optimize the food production or the agricultural production, but also to enable development of new hyper-personalized foods? So here I would like to give some examples from sensorization of things. So let's start with food. So here I will introduce to Food Scanner, which is a product coming from Spectral Engines. That's a VTT spin-off that measures the macro and micronutrient composition through a near-infrared spectroscopy system, and also including the total energy of foods. This is pretty much something that, of course, you can also find from the packaging of the food products, but also this is something that the consumers have either difficulty in following and understanding, but also when it comes to fresh products, fruits, vegetables, or meals, this kind of information is impossible to get. So the Food Scanner data communicates with the consumer through a mobile app, for example, in a clear and easy to understand way. The next important thing here is, of course, sensorization of me. I mean, as a consumer. There are, of course, this next generation rings and watches that can collect information related to your health and well-being, but there are also other ways of collecting activity level or indicators of health and well-being status through wearable patches that can connect your skin or through stretchable textiles that can be part of your everyday clothes. At this point, I would like to also mention VTT's Me and My Food concept. So, and Me and My Food includes sensorization of food through foodomics, ingredient and food knowledge data platforms. And together with sensorizing the health and well-being of the individual consumer, we create Me and My Food, so food production based on taking into account individual needs and values and preferences of the consumer. So in this new concept of hyper-personalized production, obviously data and digitalization are the key elements so that the food production and diet-related recommendations are made for the individual level, not for the general consumer. So before I move forward on how data can be utilized to create new business opportunities from the perspectives of hyperlocal sourcing, production, and distribution, I would like to touch base briefly to the impact of COVID-19 pandemic on consumers' food behavior. And this is a very fresh study funded by EIT Food. And the consumer study was done in 10 European countries, as you would see, quite diverse, from Spain, Sweden, Germany, UK, Poland, Italy, France, Greece, Finland, and Romania, in a total of 5,000 adult consumers who have met the criteria of being responsible or co-responsible for grocery shopping. So, yes, as we expected, COVID-19 disrupted the food shopping. And there has been a sharp increase found actually almost 50% in food shopping online, where home delivery accounted for the majority. And we also found an equally large increase in bulk shopping. And almost in all categories, consumer purchased more, except alcohol and convenience foods. So saying that, another outcome of this massive study was that choices were driven by sustainability and health during the pandemic time. And almost half of those surveyed said that protecting their health is more important as a result of the pandemic, which was reflected that they opt for more local foods, less food waste, and there's now a little bit of a paradox. So they opted for buying unpackaged or biodegradably wrapped products for environmental reasons. But on the other hand, they also opted for buying more packaged goods because of hygiene concerns. During this time, consumers avoided artificial additives and preservatives from their foods, and they have dieted also for weight control. So as you can see, the ongoing pandemic clearly disrupted the food system and the consumer landscape, and accelerated the demand for local and new ways of distributed manufacturing. So there are three critical questions at this point in order to be able to create value through local and distributed manufacturing. How do we operate with shorter supply chains and home delivery from field to home? How do we move away from cascaded distribution and long delivery times? How to enable also local personalized food production and distribution. So here are some examples. Of course, during this time, also online food delivery service and ghost kitchens that sell exclusively or predominantly through digital channels skyrocketed due to disruptions in restaurant and catering services, and they have also enabled some already new business opportunities. Another interesting move was that in order to enable the contactless and humanless outdoor food delivery, robots started to be utilized more than before. So some examples you can see from a startup company in Estonia is the Starship, which has been utilized to deliver also food shoppings through robots. And another interesting example was coming from US in collaboration with PepsiCo. Pepsi snacks and drinks were produced in a university campus through Snackbot. And some examples also from the new smart machines that minimizes the human touch could be also one of the new norms after this pandemic time. And here you can see some examples on the left corner, a fresh salad making machine, and then a burger manufacturing hub in the middle, and then also on the left lower corner, a fresh bread baking machine, again starting from scratch. And then an interesting case is from again US, from California, an en route pizza making line or truck, which the pizza making process is done together with robots and humans as well. But then there are, if I remember correctly, 60 different 60 GPS integrated ovens, and the truck which is nearest to the point of purchase is taking the order, so that optimizes the baking process, the making of the actual pizza, so that it delivers the pizza to the consumer just right out from the oven. And last but not the least, I would like to also end my presentation by giving examples from VTT focusing on consumer-centric food production. And here you can see next generation smart machines. In the left corner, there is a drinkable, a machine that makes either a drinkable or a spoonable product. And also on the right corner, you can see the cake in a cup machine that makes sweet or savory cakes, where the consumer has the opportunity to fine-tune the macronutrient and micronutrient composition. So as a key message, I would like to say that harnessing food-related data and digitalization from farm to fork will not only enable smart and sustainable food production, but also can create new business opportunities by catalyzing production for the individual consumer. Thanks for your attention, and I'm ready to take the questions.
Thank you so much, Nestle, of course, to present this very interesting, and it's always nice to see actually real food. I just want to say that I don't know if there is any consumer satisfaction of the robotic made pizza. That should be very interesting. And I was wondering if we have any Italians from the audience, if they would like this robotic made pizza, but yeah, that's the way to go. And then I pass the floor to Martin, if there is any questions from the audience from the last presentation.
Yes, there definitely is, and there are many more questions. So we try to get or use the remaining time in the best possible way. So maybe also to all those that get the question, keep the answer short and sharp, but maybe linked to the last presentation or the one we just heard. So it says, this is a very individual approach. How should it interact with cultural and social traditions like common meals?
I guess the question is to me?
Yeah, that's, yeah.
Okay. Yeah, this is good question, actually. So can you repeat once more? So common, I
No, no
didn't get the
problem.
last part.
It's a very individual approach, and how should it interact with cultural and social traditions like common meals, so coming together
Yeah.
for that?
Okay. So, of course, as individuals, our culture and social interactions is also in our DNA, I would say. So, obviously, that's something that has to be also integrated when we are creating this individual or personalized food production. But if you are more asking from the perspective of the eating occasion, that's of course you can eat together with your family and colleagues and so on, but then you don't need to eat the same food. So I would approach it from that angle if if that was an answer to the question.
Yeah.
Thank you very much.
Yes. Please, Martin.
Yeah, another one is referring to the talk by Professor Welzien from the Leibniz Institute. And
Sorry, Martin. Should
sorry.
we actually invite now all the speakers on the panel?
Yes. Sorry.
please.
Yeah. So yeah, you are all invited. We will now look
Exactly.
into the questions we got remaining, and we do have some. So the audience was quite interested. Great to see you all. And the first one is referring to the presentation by Professor Welzien, and it says, or it states, what kind of innovation do you envision with regards to diversification of input data to mitigate the problem of trusting predictions based on past data?
Okay, that's a very good question and a very challenging one. To be honest, I don't have the answer ready at my hand. But like I said before, we definitely need to put together all the domain knowledge that we have, and the domain, that's a phrase from the IT technology guys. So that means we have to have the agricultural knowledge, we have to have the breeding knowledge, we have to have the process knowledge, and we have to look into how we can change those processes. And just trying to give one short example. If we're training a system to identify images and to identify the status of a healthy and a diseased plant and differentiate those, this works very well, and we have high accuracy in the detection. But if we're looking for new and innovative ways, we first of all have to define the data sets, and we have to look into which sort of information will can we use to train the machine. I'm using the example always of a preschool class. So you have a preschool class and you're trying to teach this class something. That's our machine learning algorithm. And if you don't know what you want to train the machine on, it will not get there. And if we don't have the knowledge to analyze the result and make sure that the result is valid, then we're at the hands of machines. So I'm really pushing into the direction of we need to train the machines to have those intelligence inside of the machines. Then these machines need to educate us humans again. So we have to have a closed cycle of training and educating each other. And this is the knowledge representation that is really crucial there, so that the humans are being trained together with the machines and it's not a one-way street. I'm always saying that's a Google effect. Yeah, Google Maps. Nobody is able to read a map anymore these days. It was common knowledge only one generation ago. So we really have to make sure that everyone is on board and that we as humans are increasing our knowledge with the machines. Yeah.
Thank you very much. That sounds like a very dynamic process. Another question is addressing the presentation of Jürgen. And it states, so apart from farmers' organizations, do other organizations along the supply chain, for example, processing, retail level, can play a role in adoption, a role in adoption support process?
Honestly, I might think that they probably can play a bigger role than the farmer organizations. You can like it or you can't like it, but if we try to create adoption of digital technologies with farmers, we have still a long way to go. You have the early adopters, but still a lot of work is to be done on digital skills, for instance. On the other side, if tomorrow a potato processor or a retailer would say, look, you can only deliver the data, only deliver the potatoes when you bring me also the data, or I will not accept the potatoes anymore, it would create a huge push. So for us, this is a way to explain, because we are from the farmer side and we are there to support them first, to step into the digitization as quickly as possible themselves so that they can stay in control and take the first step themselves. Because when it comes, and I don't want to create an opposite from the beginning or the end of the chain, but if it's pushed towards them, they will probably less in control, or they will have less time to adapt. So now is the moment for them to organize themselves, to put themselves in control, to put themselves at the steer of digitization. So yes, they will play a big role, the other actors in the chain, and farmers have to move fast. This is my answer.
Thank you very much. We have another question for Melika, and one of the audience members is asking, and it's a question about IOF 2020. So it is very good that farmers are involved in this pilot studies, but he or she asks, are the policymakers also involved?
Thank you very much for the question. The answer is yes. So, and actually, the IOF project, as stated before, is one of the really flagship projects of European Commission. And therefore, we are in tight communication and coordination with the European Commission and with the relevant bodies. One of the things that IOF will provide at the end, so basically in spring 2021, will be a policy recommendations from our perspective. So, in order to be short, the answer is yes, they're involved.
Thank you very much. And we have a question for Karen Ammann. You were talking about the important skills, or also soft skills, that are needed moving forward. Do you think, or do you feel that we are ready, that we have enough of those soft skills, or do we need more support structures in training people?
Thank you for the question. If we look at the workers in the food industry, I think that we need to figure out how to adapt our current training methods to provide more soft skills. And one of the issues which you can see when we discuss this with the food companies, that is language. Because the food industry is very inclusive, and in many food companies you find different nationalities working together. And some of the food companies also have, let's say, English as a corporate language. So this means that basically there is a need to learn more language among food industry workers. So that is definitely something. And I'm not sure language skills is currently on the curriculum for technical colleges or other places where you educate the workers. So that is one issue. Another issue of soft skills is also, a mindset for working in projects. And that is also something which needs to be developed.
Yeah, thank you very much. Now we have the full circle, and we could go back to the last presentation. And food seems to be a very interesting thing, so we got quite a bunch of questions on that. So how to increase the willingness of European consumers to pay extra prices for sustainable foods or products, because at the end of the day, the cheaper product wins. And that's a question for Nestle.
Yeah, I have already unmuted myself. I was feeling that it's going to be for me. Well, actually, it does not necessarily go like that, that the cheapest product wins in the end. I think when it comes to the consumer, it is taste is critical. Of course, price is one of the factors as well. But then we have also made other consumer studies, and the one that I have showed, I just showed only a very condensed outcome of it, is that people also, especially during this pandemic time, consumers have opted for more sustainable choices. So they have reduced the meat consumption. They have also increased more, fresh fruits and vegetable consumption, but also opted for this plant-based, non-dairy or non-animal products. And then also they valued more, living according to the planetary boundaries. So there will be a force majeure, I believe, that's coming from the planet Earth itself. I mean, we are all now in virtual world, not even able to travel and make all these, forced sustainable measures. So I think this was also one issue which has really disrupted the consumer landscape, and it will also continue to disrupt it in the coming 5 to 10 years. At least that's my vision.
Thank you very much. Another question is referring to the term informatization, dear Cornelia. There was a lot of excitement about the term. And the question is, can informatization be defined as the digital collection and transformation of data into usable data or usable information? Sorry.
Yes, I like this definition because the literature also shows the knowledge pyramid, and that's actually doing or representing exactly that. You have the base layer of raw data, then you have the accumulation of data with pre-filtering and things like that, and then you have the first level of deriving a first level of information from data, and then this information needs to be re-evaluated to actually derive knowledge and insights and to derive decisions from that. So this is within data science, these 4 steps to actually arrive at the goal, and a machine which has a cognitive system installed actually needs to process all these 4 different steps. And this is why I chose, or actually I did not invent the name informatization, but I also picked it up from the literature. I have to admit that I don't remember anymore who was it who brought it up. Yeah, but it's exactly that, and I think Spiros has also summarized it in a similar way. The digital transformation that we're seeing right now is that we're making much more use of data that we're gathering today. And that is something that we have to always keep in mind, that it's really nothing new, and we will need all the domain technologies, all the domain knowledge to derive this information and this knowledge, and to reach a new level of knowledge that we can apply to our systems.
Great, thank you very much, Cornelia. And the last question for the very last 2 minutes is for Jürgen. And someone is very interested in what kind of incentives are there, or what is an incentive of the farmer to press the green button?
That's a very good question. And our steering group is spending late night meetings on how we are going to convince them for that. And if, to be very transparent about it, if they would really be willing to pay for that or not, for instance. But if there is one thing that we already discovered that can convince them, it's not necessarily money, but you have to bring value. And the value that they appreciated up to now most is lowering administrative burden. The app that we launched on the one that they are using now to support them in digital auditing is changing their job from having such a pile of paper, invoices, analyses, something that makes them very nervous if they know that they are going to become audited. They phone us and they say, okay, where can I find this app that is available? Please support me because tomorrow the auditor will be here or next week and I want to be ready. So I can answer it by saying if you lower administrative burden, they're interested to say yes. Next year, we will start a very interesting project with the industry on seeing which business model could be set up with a farmer and what does he want? Should we pay him? Should we give him some advice as reward? So we will test it then. And if you invite me again, I will bring you the results.
I think someone in the ministry will note this down. So thank you very much to all of you.
Thank you.
Maybe Spiros.
Just to close up, right, Martin? Yes, I would like to thank all speakers. You actually gave us a very wonderful presentation. I feel actually that you gave examples of digitization for the whole value chain. We hope to have more time because more questions would actually arrive and be answered, because that's a very timely and very important area. And it was very good to see, not only from the farmer's perspective, but also food industry and consumers. So that has been really nice. And I would like also to thank Martin for facilitating all of this process. And again, thank you very much also for the audience, the virtual audience. And I think we should be able to close this session, right, Martin?
Yeah, thank you very much. So this has been the first session of track number 1, Sustainable Digital Transformation of the Agricultural Value Chain. And we will now have the opportunity to go straight into a coffee break. And as it is common in this conference, you're invited to be part of the digital networking. And you can actually enter the networking room by clicking the meeting button in the lower part of your screen. And another important note, in this lunch break, you will be invited to participate in an online voting we prepared for you. So during the break, different questions will appear on your screen, and one question at a time every 5 minutes. So please participate in this anonymous voting, and the results will be presented in the next session of track 1. So thank you to everyone. And if you are really excited about this conference, you can also tweet about it by using the hashtag AgriDigitalEU2020. And now it's time for a break.